Hello everyone, today we are going to learn the second lesson, unit 4, which is the probability. First, before we say the meaning of the probability, we need to know the new word, which is event. What's the meaning of event? It's something happened, right? It's rain, it's event, it's called event. I go to school, it's event. My father bought a new car, it's event. All of this is called events. Plural is called events. So events has a new type, has a three type. We have three types of event. First one is called certain event. Second one, possible. Third one, and the last one, impossible. First one, certain event. Certain event, it means that it's sure it will do this work. What's the meaning of certain event? If I say that the sun comes from the east, is raised from the east, it's a certain event. If I say that the winter is much or more colder than the summer, it's a certain. I'm sure for this word. Okay? So we give the name of this event is certain event. Certain event. The next one, impossible event. What is the meaning of impossible? It will never happen. If I say that a cow will fly, a goat will fly, it will never happen. It's impossible event. Okay, if I have a car and I say that a car will fly, it's an impossible event. An impossible event, so it will never happen. Okay, and the last one, the possible. Possible mean maybe no, maybe yes, maybe no, maybe yes. If I look to the cloud, it will be rain or not. I'm not sure if it will be rain or not. So I say that impossible, a possible event. I don't know certainly what the meaning of raining. I don't know if it will rain today or tomorrow. I don't know. It may be rain or not. So I'm not sure it will be possible event. So I have only three types of events. First one, certain, that I'm sure for this event. Second one, impossible, it will never happen. And the third one, possible. Maybe yes, maybe no, maybe not. Okay? So, the next one, calculating the probability. What's the meaning of probability? Probability, it may be happen or not. It comes from events. So first I need to get that new word, which is event, before the probability. So probability mean something happen. Certain event, possible event, impossible event. Okay? Probability. Maybe yes, maybe no. Okay? So the probability of anything is the probability of the types of events, which is certain, possible, and impossible events. First kind, the probability of the certain event. It will take the value of number 1. I'm sure that the winter will be colder than the summer. I'm sure for that. Okay? Or if I say that if I jump up, I will come back down again. Is the certain. I'm sure for that. I'm not sure for this. If I'm not sure, it will be possible. Maybe no, maybe yes. Okay, but if I jump up, if I go up, I will be back down again. It's a certain event. So it will be get the number 1. The value of any certain event equal to number 1. The next one, the next event, impossible. It will never happen. If I say that a goat will fly through the window. It will never happen. So it will be an impossible event. So it will get the number 0. number 0. So sure, 1. Not sure, no, not sure is possible. It will never happen. It will take the number 0. But the next type, which is lying between possible, impossible and certain. I'm not sure. Maybe yes, maybe no. It will call possible even. It's lying between certain and impossible events. So it will take any number between 0 and 1. As we learned before, between 0 and 1, there is an infinite number between 0 and 1. 0.1, 0.2, 0.3. A decimal or fraction numbers, as we learned before. So any possible event will take any value between 0 and 1. Okay? Okay, if I say that a goat will fly through the window, is possible or impossible or certain even? Goat will fly. It's impossible. Impossible. It will never happen. So it will be impossible even. And take value equals 0. Okay? Next one. If I need to getting a number 5 when a die is thrown once. If I have a die like this, I know the die have 6 numbers from 1 to 6. If I throw this die only one time, if I need to get a number 5, when we throw this die only one time, once time, okay? This even is called possible or impossible or certain even. It maybe gets 5, maybe gets 4, maybe gets 6. I'm not sure for getting 5. So it will be certain? No, it will be possible. Maybe 5 or not. I'm not sure for that. It will be possible even. It will take the value between 0 and 1. Okay? Third one, if I need to selecting a green card from a bag that contains 15 green cards. I have a bag, and this bag contains only 15 green cards. If I need to get any one of these cards, and if I need to get a green card, what's the event? What's the type of this event? Possible or impossible or certain? Impossible, no. It will never happen to get a green card? No. It's maybe. Okay, it may be. So impossible will not get. So I have a certain or possible even. If this bag contains many types or many color of cards, I will take the possible. Maybe get green or blue or red, but this bag only have 15 green, only green cards. So if I take randomly, if I take blindly, I can't see anything. I will take any cover between my eyes and get any card of this bag. I will get a green card. Okay, so I'm sure that I will get a green card. I'm sure. What's the meaning of I'm sure of events? It will be a certain event. Because I have only one color, which is green. So if I choose any one of these 15 cards, it will be green. 1 or 2 or 3 or any one of these cards, it will be green. But if I have many colors in this pack, it will be maybe green, maybe red, maybe blue. I'm not sure. So it will be a possible even. But if I have only a green card and I asked you if you need to get a black card, what's the kind of this event? I have only a green card. But if I need to ask you to select a black card, this event is impossible. Impossible. It will never happen because I have all colors will be green. I have no black cards. Okay? Next one, the rule of the probability of an event. This is the rule of any probability of any event. P of E. What's the meaning of this symbol? P get from probability, and E get from event, probability of any event. Okay? Probability of any event. This is the symbol of this rule. P of E, probability of event, probability of events, equal to the fraction, the numerator get the number of occurrence of event E. What's the meaning of this? I need to get the number of occurrence of the event E only. Okay? The number of occurrence of event E only. Over, and the denominator get the total number of all possible outcomes. All outcomes. If I have a bag, this bag contains 3 colors of cards: red, blue, green. If I need to get the green, I will first get the number of the green cards in the numerator, up and down. We will get the total number of all cards, red and blue and green, like this. This probability is called probability of the green cards. Okay, so the rule probability of any event equal to the number of occurrence of the event E and the total over the total number of all possible outcomes. Let me take the first example. When we tossing a regular coin, we have a coin, 1 pound, okay, like this, coin. When we tossing a regular coin once, all possible outcomes are or a head, we have a head, or a tail. We have only 2 outcomes. We have only 2 outcomes. So the number of all possible outcomes that I will get, I'm sure that I will get, or a head or a tail. No more than a head or a tail. Okay? So the number of all possible outcomes are equal to events. We have 2 events. The first event will be a head, and the second event will be a tail event. Okay? If I ask you the probability of getting the head, the probability of getting the head of this coin, first one, I will do the rule. First, I need to get the number of occurrence the event, which is here, even called here, head. How many head can you get from one coin? I have only 1 head. Okay, if I toss any coin only 1 time, I will get a head or a tail. I have only 1 head and only 1 tail. Okay, so the number of occurrence, the event head, equal what? I have only 1 head, so it will be equal to 1. Okay, over the total number of all possible outcomes. If I toss any coin, I will get a head or a tail. I have only 2 results, no more than 2. So all possible outcomes will be 2. So it will be 2. 1 over 2. 1/2. So the probability of a head of this coin will be 1/2. Next one, if I need to get the probability of the tail. How many tails can I get from only 1 coin? I have only 1 coin with 1 head and 1 tail. 1 and 1. So the probability, the number of the occurrence of the event tail, I have only 1 tail, will be equal to 1 over the total number of all outcomes, all results of this coin. I have only 2 results, which is a head or tail. Head or tail. It will equal to 2. It will be also 1/2. 1/2. I have no more than a head or a tail. There is some notes that say that the sum of the probabilities of all possible outcomes equal to 1. What's the meaning of this? If I get the probability of the first one, which is head, equal to 1/2, and get the summation with the probability of the tail, which is equal to also 1/2. The summation of all events, 1/2 plus 1/2 equal 1. The summation of all probability. The summation of all the probabilities of all possible outcomes will equals, in any example, will equal to 1. Again, the sum of the probabilities of all possible outcomes equal to 1. Next one, when rolling a fair die once, die, like this. This is called die. When rolling a fair die once, all possible outcomes we have 1 or 2 or 3, 4, 5 and 6. We have no more than 6 and no less than 1. Okay? We have possible outcomes from 1 to 6. So the total number of all possible outcomes equal to 6 events. We have only 6 events. We have only 6 events. So if I asked you the probability for getting number 1, first we do the rule, number of the occurrence, the event 1 over the total number of all possible outcomes. Okay? First one, number of occurrence of event 1. How many times can I get number 1 if I throw this die only one time? Look at this. Rolling once, only one time. How many times can I get number 1? Sure, it will be only one time. I have only 1, only 2, only 3, only 4, only 5, only 6. We don't have 2 ones or 2 3s. We have only 1. We have only 2. Okay? It's only one time for each of these events. I have only 1 time for event 1, only 1 time for event 2, and so on to event 6. So the number of occurrence of event 1 will be equal 1 over the total number of all possible outcomes. How many results can I get from this die? I will get 1 or 2 or 3 or 4 or 5 or 6. How many times? How many results? It will be 6 results. So the total number of all possible outcomes will be 6. It will be 1 over 6 or 1/6. Okay? Next one, probability of event 2. How many times can I get number 2? Is also, I have only 1, 2. Only 1, 2, no more than 1. Okay, so the number of occurrences of event 2, it will be 1 over the total number of all possible outcomes equal to, I have also from 1 to 6, the total number all equal to 6 results, 6 events. Okay? And the same thing, the probability of number 3, we have only 1 3, and the total number of all possible outcomes equal to 6, it will be 1/6. The same thing, probability of number 4, we have only 1 4, and the total number equal to 6. Probability of number 5, we have only 1 number 5, and the total number equal to 6. The same thing, we have only 1 6, and the total number of all possible outcomes equal to 6. It will be 1/6. All events are equal to 1/6. The summation, if I need to get the summation of all possible outcomes, I will get 1/6 plus 1/6 plus, it will be addition for 6 times, 1/6 plus 1/6 plus 1/6 plus 1/6, the last one, it will be 1 plus 1 plus 1 plus 1 plus 1 plus 1 equal to 6. And the same denominator, which is 6, it will be 6 over 6, which equals to 1. So, it's the rule which is say the summation of all probabilities of all possible outcomes equal to 1. If I need to ask you the probability of getting a prime number, remember what the meaning of prime number? Prime numbers that have only two factors, which is 1 and itself. 1 and itself. It starts from 2, 3, 5, 7, 11, and so on. So, in any die, we have only 2 and 3 and 5. We have only 3 prime number of this die. So, the probability of getting a prime number, we have 1, 2, 3 events. The number of occurrence, the event, which is the event here, is called a prime number. We don't not to get the number 2 or number 3. No, I get the all events. I have 1, 2, 3. It will be happen for 3 times. So it will be 3 over. The total number of all possible outcomes. The total number of all possible outcomes. It will be the same thing. We have all numbers from 1 to 6. It will be 6. The same thing. Okay? Through 3 over 6. We need to put this fraction in the simplest form by dividing by 3 both of the numerator and the denominator. It will be 1/2. Okay? The number, the probability of getting a prime number, it will be 1/2. If I ask you to use the probability of getting an even number, we have only 2 and 4 and 6. We have 3 events, which will be an even number from 0, 2, 4, 6, 8, and so on. So how many times even number repeated occurrence? It will be 3 times over all possible outcomes of this die equal to 6. It will be the same thing, 3 over 6, it will be 1/2. Okay, it's very simple. And the last one, if I have a bag contains 7 red balls, 7 red balls and 2 green balls, 2 green balls, and the last one, the last color, 3 yellow balls. I have a bag, have 3 type of color, red, green, yellow. Red, green, yellow. If a ball is chosen randomly, I will cover my eye, I will not see anything in this bag, blindly, okay? From this bag, the probability for the first event, if I need to get the probability of choosing a yellow ball, first one, we will write the rule, probability of getting yellow, like this, equal to, first one, do the fraction, the numerator will get that number of occurrence, the event yellow. How many times can I get the event of yellow balls? I will contain the yellow balls. How many yellow balls can I get from this bag? I have only 3 yellow balls, so it will be 3 events. Again, the number of occurrence, the events of yellow, I have only 3 balls, so it will be 3 yellow balls. Over the denominator will be the total number of all possible outcomes. All possible outcomes, that mean all results, the summation of all results. I have 7 red balls, plus I need to get the total number of the balls. I have 1, 2, 3 types of balls. I will get the summation of this type. First one, 7 in the red balls. Second one, 2 in the green balls. And the last one, 3 in the yellow balls. So the total number of all possible outcomes will be 7 plus 2 plus 3, it will be 12. 12. So it will be 3 over 12. 3 over 12. If I need to get this fraction in the simplest form, dividing by both of the numerator and denominator by 3, it will be 1 12 divided by 3 equal 4. It will be 1 quarter. 1 quarter. Next one, if I need to choose a black pole, how many black poles can I get? I have only, first one, red, green, yellow. Red, green, yellow. I don't have any color like black. So the number of occurrence of number, let me get this. First, put the rule, probability of the black poles equal to. How many times can I get the black poles? I have only 3 colors, red, blue, yellow. Red, green, yellow. Red, green, yellow. I don't have any black poles. So the number of occurrence, the events black equal to 0. I don't have any black pole. And the total number of the all possible outcomes is the same. It will be 12 poles. So 0 divided by any number equal to 0. Okay? It will be 0. The last one, if I need to choose a non-yellow pole. What's the meaning of non-yellow pole? I need to choose any pole, any color without yellow. I need to choose a red or green. I don't need any pole with a yellow color. So I have 2 rules. I will take the summation of the red and green. The first one, the first method, I will take the summation of the red and green. The summation of red and green will be red 7, green 2, it will be 9. So the probability of non-yellow will be equal to 9. And the total number of all possible outcomes will be the same thing. Will never change. The total possible outcomes will be 12. If I need to get these numbers of sums form, dividing by 3 equal to 3 over 4, 3 quarters. This is the first method. And the second method, I need to get all kind of poles except the yellow poles. I need to get all kinds of poles, red or green, except yellow poles. So I will get the all possible outcomes. The total, the summation of all possible outcomes will equal to 1. I need to know the total possible outcomes. If we get to the summation of all possible outcomes will be 1. So if I get 1, and subtract from 1 the number of yellow poles, I get all possible outcomes except yellow. Again, I need to get all possible outcomes except yellow. So all possible outcomes, the number of these even equal to 1. Possible, I know that the number of these poles equal to 12 poles. So it's in a certain even. It will take a number 1. Okay, so I need to get all the poles, red or green, except yellow. So we will get number 1 and subtract from 1 the number or the probability of the yellow poles. The probability of yellow poles. Probability of yellow poles equal to 1 over 4. 1 over 4. This is the probability of the yellow pole. So 1 over 4. 1 minus 1 quarter equal to 3 quarters. In the same way, from the first or the second method, it will be the 3 quarters. Again, I need to get, if I need to choose a non-yellow pole, what's the meaning of the non-yellow pole? I need to get all kinds of all color. Any pole except the yellow color. So I first method, I get the summation of the red and the green poles, which is 9, and the probability of the red and green equal to 9/12 equal to 3/4, or I will get all possible outcomes and subtract from it the probability of the yellow poles, which is 1/4 that I calculated before. 1 minus 1/4 equal to 3/4, and that's it. Goodbye.